First type of heat exchange in a process is the heating and cooling processes, where heat is absorbed or released from the system. So when you want to heat some water to make coffee, for example, um, how much heat would you need? Of course, this is gonna depend on how hot you want it, right? So it's gonna be proportional to the change in temperature that you want. So, which is the difference between the final temperature you want to make it minus the initial temperature you start with, right? So, uh, if you want to calculate the amount of heat needed, in this case, is, as we said, is going to be proportional to the change in temperature that is needed. So it's going to equal a constant times a change in temperature. That constant here is called the heat capacity. But if you want to standardize that constant based on the amount of sample you want to heat, because of course, different amounts of water would require different amounts of heat. So if you want to standardize uh, the amount of heat per unit mass, you have to take the equivalence or the proportionality to mass into account. So in this case, the amount of heat needed will be proportional to both mass and change in temperature, and the proportionality constant C in this case is going to be called specific heat capacity. So specific heat capacity, let's just, to avoid confusion, the heat capacity itself that does not take into account the unit mass is going to be a capital C. The small c is the specific heat capacity, which is the amount of heat needed to raise the temperature of 1 gram 1 degree Celsius, right? And based on this, you can define units of thermal energy uh, depending on the units of mass or temperature that you're using. So if you are raising the temperature of 1 pound of water 1 degree Fahrenheit, this is the British thermal unit. It's going to be 1 British thermal unit. So 1 British thermal unit is 1,055 joules. If you consider the amount of water in terms of grams, so if you want to raise the temperature of 1 gram 1 degree Celsius, this is going to require one amount of heat that is equal to 1 calorie. So 1 calorie in terms of joules is 4.18 joules. In chemical reactions, we actually usually like to quantify substances in number of moles, and this is why we need to define the amount of heat needed to heat or cool a substance with respect to the amount in moles. And the proportionality constant in this case is going to be the molar heat capacity. It's going to be the amount of heat needed to raise the temperature of 1 mole. The quantity in this case is 1 mole of the substance, 1 degree Celsius. The specific heat capacities are constants that has been measured for different substances and will be provided for any calculation that will be in a problem in a homework or in the exam. So let's do an example here. If you have a sample of water that weighs 466 grams and you want to heat it from 8.5 degrees Celsius to 74.6 degrees Celsius, how much heat will be absorbed in order for this heating process to happen in kilojoules, right? So again, we define the formula that correlates the amount of heat of your system in relation to the mass and the required change in temperature, and the proportionality constant in this case is the specific heat capacity of water, which is 4.184 joules per gram per degree. So what we need to do here is we already have the specific heat capacity for water, which is a constant. We have the mass, which is right here. All what we need is the change in temperature that we want. So, and that is going to be, so Cm times the final temperature minus the initial temperature, right? So it's going to be 4.184 joules per gram degree times the mass, which is 466 grams, times the change in temperature, which is the final temperature right here, is 74.6 minus the initial temperature, 8.5 degrees. It should give you 129 times 10⁵ joules, but the answer, the needed answer, is supposed to be in kilojoules. So you need to multiply this times the conversion factor between joules and kilojoules. So 1 kilojoule is 1,000 joule, right? So you just divide this by 1,000, and it's going to give you 1.29 times 10 to the power 2 kilojoules. That's the first type of heat calculation that you will find in the homework.